Hello there. Today we'll be doing sliding window maximum. This is our final sliding window problem, number 131. So in this particular problem, we're trying to get the max in each window position. And the brute force way to that is going to take us n minus k times n, because we're going to look at the max for each window, and there are going to be n minus k windows, as you can see here, because the last window is 3, so there's 5 windows here. So it looks like 6 windows here. So n minus k plus 1. So what's going on here, just to make sure that's correct, this is 8 minus 3 plus 1, yeah, 8, which is 5 plus 1, 6. So 6 windows. What we're going to do is retain the maximum item at each particular window spot, as well as get all the decreasing items from that maximum spot. If anything is, if we get anything that's greater, we can throw all the old items away. But if we get smaller items, let's collect them. And that way, when we slide the window, we still have the smaller items. And that's how we're going to solve it. Because if we only keep the maximum number, and we don't keep smaller items around, once we slide the window, we're gonna lose track of those smaller items, and we can't do that. So what we need to do is create a queue to store these smaller items, and remove any items that are, remove items that are smaller in the max, that are to the left of it. So 1, create a queue where leftmost item is well, the biggest, by removing all smaller items to the right, and store all smaller items to the left. Right. Next thing we do is then while we do that, we're gonna remove indexes smaller than the queue, smaller than the window size. And 3, add items to result once we hit window size. 4th, we're going to return results. So while r is less than length of nums, what we're going to do is we're going to make sure that we pop all items that are going to be smaller than our nums. Anything to the left. So q.pop. Once we have everything, we have q.append r. That's our biggest item. So for example, this particular example here, what we're gonna do is insert the first index. Oh, right, one more thing. We're gonna store the index. The reason why we're storing the index is because of the sliding window, and we can get the numbers easily. But anyways, so we have the 0. We see that there is a smaller item to the right, so we remove that small item and we put in the 1. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so we store in the 1, and we see a smaller item, we store that. So we have those two items. And we're gonna, once we reach the max state, we have to repop left. So if L is greater than Q of 0, then Q dot pop left. As we build, we need to add, when we get to this particular item here, as you can see, once we get to this particular point, we have maxed out our window of 3, and then we need to result dot append nums at Q0 and left plus equals 1 and right plus equals 1. So what needs to happen is that L needs to move up, and so we can move R to expand our window to keep the same size. So we're here 1, 2, and 3 because our window size is 3. And now we have -3, so we store -3 in here. Then at this particular point, we're just gonna keep adding this particular item, and once we move L, we see that this is greater than our L, because L is at 2 and this is at 1 index. Oh shoot, my bad guys. This is index 2, this is index 3, this is index 4. But we need to remove 1 because it's smaller than L, which is equal to 2 right now. And this is equal to 4. This is great. So then we have index 2, 3, and 4, which gives us it gives us -1, -3, and 5. And so in that window, we should grab the 5. So and we move the window, of course, with that means all of these are removed and we no longer have to look at those. And we keep moving on, looking at the 5th index, which is a 3. So 5 gets appended on, and you get the 3 there, and then you have the 6, which means we have another 5 again. And then we have 6 here as we move the L and the R, and until we hit the end of our range of items. So we have 6, and that means there's a 6 here, and that means we can remove all of these. And we keep moving left. Of course, that operation never happened again. And that's going to be our 7th. That's going to remove this one. And we're going to have 7 here. So return result. Run the code. What's going on? Must be an error somewhere. Timeline exceeded. Why is that? Did we not increment the R? Oh, that's the problem. This one's not indented. There we go. And now we can submit. Looks like these comments need to be indented. But anyways, that's the solution to this particular sliding window problem. What we learned today, again, was that we needed a way of storing the largest value while retaining smaller values to the right to maintain our sliding window. This is called a monotonically decreasing array. And by storing the smaller values to the right and deleting all smaller values, deleting all smaller values to the right, and storing all smaller values to the left, we can have a way of maintaining the max item while retaining the smaller items that are necessary when we slide our window. Hopefully, we remember this particular tool in our tool belt for when we have these types of problems in our algos for interviews. And if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below, and have a good one.